Finding the domain of composite functions. I'll admit this is a somewhat complicated process, at least maybe more so than some of the other things we've done in this course, but it's not really that difficult if you just kind of get the two steps down. When we're looking for domain, that's the x's that give us real number outputs. Okay, so we're going to do this in two steps. We're going to first eliminate any x that makes g of x undefined, because that's the first thing x is going to go into in f of x. And then we're going to eliminate any x that makes g of x a number that makes f of x undefined. That's the step that kind of trips people up, but I'm going to show you a way to think about it that's a little bit easier. All right, so here's an example. F of x is 6 over x, g of x is 1 over 2x plus 1. So both of them are going to have some restrictions on their domains, right, because there's fractions. We never want our denominators and fractions to be zeros. They want us to find f of g of x and its domain. Well, the first thing I would do is actually figure out what does that new function look like. So f of g of x means I'm going to put x into g first, get that, so f of the 1 over 2x plus 1. Then I'm going to take this expression, right, and we're going to put that in place of the x here in the rule of f. So it's 6 over that fraction. But dividing by a fraction means multiply by its reciprocal, so we actually end up with this really nice looking function, 12x plus 6. Okay, so how do I calculate the domain? It's two steps. First, where do we put x first? It first went into g. So let's look at g of x, okay? And when I'm looking here, I've got a denominator of 2x plus 1. I do not want that to equal to 0. So if I set it equal to 0 and solve, I would get x would have to be a negative a half. So the restrictions on the first function, x can't be negative a half. Now here's the second step, and this is a little bit easier way of doing it. If we've already gotten the composite function, let's just look at that end result and say, okay, when I put this together, are there any other restrictions that I would be faced with? No, it's 12x plus 6. There's no fractions, no square roots, so there are no additional restrictions. Therefore, the only thing we have to worry about is that negative 1/2. So we're going to go from negative infinity to negative a half, but not included, so use a parenthesis. Union from the negative 1/2 to positive infinity. We just punched a hole there. What if we reverse this? What if they ask us to find g of f of x and its domain? Okay, well, g of f is going to be g of 6 over x. Okay, that means I'm going to take this 6 over x and put it back in place of, here was, oops, wrong one. Here was my g of x. I'm going to put the 6 over x in place of this x right here. Okay, and it's going to look like this. That's going to simplify. This is 2 over 1, 12 over x. Okay, now this is a complex fraction. I don't like fractions inside of fractions, so we look for the common denominator. Well, it's x. It's the only one that's there. And I'm going to multiply everything on the top and everything on the bottom by x. That gives me x on the top. Distributing here, the x's cancel and I get 12. Distributing here, we get plus x. Okay, so that's my composite function. Now what about my domain? Well, where was the first thing that I went into? I went into the f rule, which was the 6 over x. That means x can't be 0. That's the only thing x can't be, because that's the only thing that will give me a 0 denominator. Then we look at the final composite function here, and what does it tell me? Well, it tells me I've got 12 plus x as my denominator. I don't want that to be 0, so additionally we're going to have to exclude a negative 12. All right, so we're going to put those two things together and say, I'm going to have from negative infinity up to the negative 12, I'm going to exclude it, and then go from the negative 12 up to the 0, exclude it, and then go from 0 to infinity.